Here's the first assignment I want to work on for this video, and it is the Chapter 5, Section 1 assignment. And you can use either one of these assignments. I'm going to use the alternate assignment because it has lots of explanations at the top of the page. But before you do that assignment, you should watch these 3 videos. When you watch these videos, you click on it, and it should open up right to the page.
So, identifying linear functions is not a really big deal. If we see that the graph of the function is a straight line, then we know the function is linear. Let's take a look at some examples. First question we're going to ask for each picture. So this is going to be a picture of...
Okay, so we're not going to watch the whole video right now, but you can watch each of those videos. They're each only about 5 minutes long, as well as looking over the book pages 300 to 303 in your online text. And if you can't remember how to get to your online text, go to the Getting Started folder. It'll remind you. All right, so now I'm going to open up the alternate assignment. All right, so now we're ready to start working on the worksheet. You can see that at the top here, it has lots of information, like I told you it would, about what a linear function is. A linear function can look like a graph of a line. It can be a list of ordered pairs. It can be a table of ordered pairs. It can even just be a sentence or an equation. So these are all examples of linear functions. You notice that in the equation form, there's no exponents on the variable. So we have an x and we have a y, but there's no exponents, and the x and the y are not multiplied by each other. So next thing we're going to do is start looking at these questions, and you're going to answer the questions based on that picture up above. It says, write the following linear function as an equation. The sum of x and 4y is 9. So here's a sentence that says the sum of 2 times x and y is 3, and here's how they wrote that equation. So sum means to add, so the sum of x and 4y just means to add those two things together. And is always means equals. So that's all you have to write for the equation. Now it says, does the graph at the right represent a linear function? Tell why or why not. Well, it certainly is a line, and it looks to me like that indeed would be a function because it has several things that it has to have. It has each element in the domain. The domain is the x value. Every x value is going to 1 and only one y value. So -4 is going to 3, -3 is going to 3, -2 is going to 3. They're all going to the same y value, but that's okay. Another way that you can tell if you have a function is called the vertical line test, and you learned about this in Chapter 4. A vertical line test means that if I were to take a straight up and down line and draw it through this, there's kind of a line, that it would pass that graph once and only once. And I could do that anywhere on here, and I would still only hit that line one time. So you would say that yes, this is a function, and it is linear, and you could say that it passes the vertical line test, and you could also say that it is linear. That would be enough. Number 3 just says to take these ordered pairs and put them in this table. So you put all the x values in the x row, and you put all the y values in the y row. So the first one would be 6 for the x and y would be -3. The next one would be 4 for the x and -1 for the y, and then so on. You would do that for each one of them. And then you would have to say if it's a linear function. Well, after you put all these in here, you'll have to see if all the x values are different and they all go to 1 and only one y value, then you'll have a function. And it looks like we have 6, 4, 2, 0, and -2. It looks like we will indeed have a linear function. Well, we'll have a function for sure. I don't know if it's linear. If it's linear, then these will all increase or decrease at the same rate. So let's see. The x values are all decreasing by 2. -2, -2, -2, -2. So that's the same rate. And now let's check the y values. From -3 to -1 is +2. From -1 to 0 is not plus 2. So it does not look like the y values are increasing at a constant rate. So it is a function, but it's not a linear function because the y values do not increase at a constant rate. Okay, standard form. Standard form is that you have some number, then the x, plus some number, b, and then y equals to some other number by itself with no exponents. This one is not in standard form yet. First of all, I'm going to put a 1 in front of the y and a negative 1 in front of the x. The reason I'm doing that is so that I can have a number there. And if there's no number in front of a variable, it's a 1. I put a negative 1 in front of the x because it was negative x. All right, well, the next thing that I'm going to do is I am going to add 2x to both sides. So I'm going to add 2x to both sides. So plus x plus x. Well, I can't add, whoops, that's supposed to be a 1. 1y. I can't add 1y and 1x together because they are not like terms. So I'm just going to write them over there by itself. And now I already have that I've got 1y plus 1x equals 4. It's very, very close to ax plus by equals c. If I were just to rearrange using the commutative property, I would have 1y, or I'll put the 1x first, and it's negative 1x. The sign has to come with it. So negative 1x plus 1y is equal to 4. And now it's in standard form. And if I had to say what a, b, and c were, a is the number in front of the x, so a is negative 1, b is 1, and c would be 4. All right, so that's how you do the first page of this worksheet. And there's still a couple other pages for you to do. So you're going to answer the questions, say whether or not these are linear functions, and then on the third page you are going to give the domain and ranges for these graphs. Remember that in a linear function like this, in a continuous function, the domain is not going to be, you know, -1, -2, -3, or something like that. You're going to say that x is between, what can x be? So in this one, it's a line that goes forever in both directions. So you could say that the domain is all real numbers. And the range is what can the y values be? Well, there's no limit on the y values. If x is -100, y is going to be some really big number or really small number too. So the range is also all real numbers. That's sometimes what you have for domain and range. In number 12, it's similar, except this time our domain never is negative. So you could say different things about this. You could say the domain is all positive numbers. You could say that the domain is greater than 0, x greater than 0. There's different ways to say the domain. And the range is going to be done similarly. The range in this is also all positive numbers, or y is greater than 0. In 13, when there's just a set of dots, then you can say that your domain is, and then you can go ahead and say that the domain of this one is, looks like there's a dot at 0, 1. So we're looking at the x values here, 2, 3, 4. So you would just type them in like this, separated by commas. And the range in this one would be what are the y values of those dots, which are 0, and then 0.5, and then next one is 1, and 1.5, and so on, up to 2. So when it's a discrete function with the set of dots, then you put the list of them. But if they're continuous, then you describe the domains and ranges. Okay, well, good luck. Finish this assignment up and turn it in for points.